Hello everyone and welcome back to the JMZ Online YouTube channel. If you're new here, we hope you enjoy the video and subscribe and turn on notifications so you don't miss the next one. Today we're working on a 236 Perkins engine block out of a 180 Massey Ferguson tractor. Starting off here, we've washed the block in the spray cabinet and tackled the exciting process of scraping away the old gaskets. Unfortunately, cleaning like this is just part of the job. With the block clean and the gasket surfaces scraped, the block is getting fixtured on our RMC 1000 boring and surfacing mill so that we can get started on our machine work. The engine is getting a complete overhaul, but in today's video we're focusing on the process of removing the old cylinder sleeves and installing the new sleeves that came in the Massey Force overhaul kit that we sold to our customer. After checking the OD of the new sleeves against the specification for the diameter of the parent bore of the block, we can do a bit of quick math to find the dimension to set our cutter to in order to bore out the old sleeves. While there are many methods for removing old cylinder sleeves, we have found that boring the old sleeve paper thin is the best option to avoid unnecessary damage to the engine block that can happen if a puller is used improperly. In this case, we're setting our cutter to 15 thousandths of an inch smaller diameter than the parent bore of the block. After centering up on each cylinder and boring the old sleeve to this diameter, the outer walls of the sleeve will end up being just over 7 thousandths thick. With the machine roughly centered over the first cylinder, the centering finger runs at a low RPM inside the cylinder, and a dial indicator on the machine displays the reading. By moving the X and Y axis of the machine table, we can ensure the indicator is running true, indicating that we are perfectly centered on the cylinder and can lock down the table so it doesn't move. I started the cut by hand before engaging the Z-axis downfeed of the machine to begin boring out the cylinder. This cut is effectively increasing the bore diameter by around 170 thousandths of an inch, which is a pretty significant cut. We would never take a cut this large for a finish operation, but this instance is considered a rough operation, so here it's okay. The sleeves in this engine are a flange type sleeve, meaning the top section of the sleeve has a step which is a larger diameter than the rest of the sleeve. As such, we stop the machine after boring nearly 1/4 of an inch down so that we can verify that we are truly only boring the sleeve and aren't cutting into the parent material of the block. After breaking off the flange of the old sleeve, we get a clear look at the counterbore of the engine block and also can see that we're indeed not cutting into the parent material of the block. Obviously, it would not be good if we had been cutting into the block itself, but it would be better to catch it here than to bore all the way through the entire cylinder and then discover that we had been cutting the entire block. With confidence that our cutter is set to the correct diameter and we're accurately centered on the cylinder, we can go ahead and engage the machine again to finish boring through the cylinder sleeve, which in this case is over 9 inches long if I remember correctly. When we look down the cylinder, we see that all that's left of the sleeve is a very thin wall, and usually the bottom 1/8 inch or so of sleeve breaks off as the cutter pushes through. The process always makes a mess of chips, and at this point we can grab something like a pick and simply push it in between the sleeve and the block, and it breaks the sleeve out. Real quick, I wanted to give you guys a quick Labor Day weekend sale tip from our friends over at Michael Pro Tools. Now through midnight on September 6th, their fully loaded tool chest is $159 off. The tool chest comes loaded with 1/4 and 3/8 drive chrome sockets in the top drawer, a full wrench and screwdriver set in the second drawer, hammers, chisels, files, and more in the third drawer, and my personal favorite is the fourth drawer, which comes with a complete set of deep and shallow metric and inch impact sockets. We've been an ambassador for Michael Pro for quite some time now, so you've likely seen us using many of their tools in the shop and videos. Maybe you aren't ready to buy a complete tool chest yet, but some of their other small tools like the T-handle Allen wrenches or the spiral grip combination wrenches are used daily here in our shop. Be sure to check out the links in the description or visit gomichaelpro.com to shop, and with that, let's hop back into the video.
So how'd I do?
I think you did just fine. Made yourself a sheet of cast iron paper.
Now for the commenters who take things a bit too literal, paper is actually closer to around 3 thousandths thick, and here we're nearly double that. So it's just a phrase, you get the point. It's incredibly satisfying to watch this thing cut in slow motion. Off the top of my head, I don't know the Z-axis feed rate, but on the spindle we're spinning around 400 RPM on a cut this heavy, and you can definitely see a little bit of wobble happening. Again, it's a rough cut, not a finished cut. At this point in the video, I want to ask you all to drop a comment for my father and I to read. But don't leave us too many because then he just sits there on the phone all day reading them while I'm doing the machine work. Obviously that's a joke, but we really do try to read all of the comments that we can. As you can see, the machine does move fairly slowly and it takes several minutes to bore each cylinder, so the best practice is to find something else to keep yourself busy nearby while the machine does its thing. Maybe someday this YouTube gig will fund a new CNC block machine that would do all 4 on its own, but in the meantime we'll have to stand nearby and move from one cylinder to the next on our own. With all 4 cylinder sleeves removed from the block, we can get a clear view of the parent bores, which appear to be in very good condition compared to some that we've seen. However, they are very dirty from who knows how many years and hours of use on this engine since it was last overhauled. As such, I decided to take about 15 minutes to throw the block back in the spray cabinet and do a bit of cleanup around the machine. To help get the bores nice and clean, I used a ball hone on the drill and gave each bore just a few strokes. This isn't excessive enough to remove any actual material from the block, but it takes care of the buildup and grime that was left behind the sleeves. For the next step of the process, we have the block back on the RMC 1000 and are using our surfacing head with a CBN cutting insert to cut the deck of the block. After decking the block, we also need to clean up the counter bores so that they're cut to the correct depth for the flange of our new cylinder sleeves. After measuring the diameter of the counter bore, we can grab one of our counter bore cutters and set it to the proper diameter for the flange. I don't know whether the counter bores here were factory or if they had been done at some point in the past, but the cutter used left a significant radius in the corner and a very small flat area for the flange to sit against. However, the cutter we use actually comes to a pretty sharp point, leaving a nice and wide flat counter bore surface. As a starting point, we simply cut the counter bore until the previous counter bore just cleans up, at which point we grab a deck bridge with a dial indicator to check the depth against the specification, as well as the replacement sleeves. While the spec calls for the counter bore to be between 150 and 152 thousandths deep, the flanges on the new sleeves were a bit thicker, so we decided to cut the counter bore to 152 thousandths in order to have the top of the sleeve protruding the correct specification. While decking the block and cutting the counter bores is sometimes looked at as unnecessary, we believe it's best to do the work right while it's here in the shop and make it as good as it can possibly be, as opposed to wishing we had done the work when it comes back. On these 236, the sleeve fit is essentially plus or minus 1,000th from zero, meaning that sometimes they require a bit of persuasion, but in this case we have a slip fit and they slide into place very easily. It's also not uncommon to find that the parent bores of the block are warped from years and years of heat cycles or even additional damage from other causes. In this case, the block was in very good condition, so the sleeves fit into place perfectly without any distortion. Now that the sleeves were all installed, we removed the old cam bearing from the block so that we could do one final wash in our larger spray cabinet, which runs a caustic solution that is much stronger than the smaller spray cabinet shown earlier in the video. When the block comes out of the spray cabinet, it's rinsed thoroughly to ensure that no cuttings or debris are left in any of the passages. I don't know what they used for primer back in the day, but it must be pretty good if it didn't come off after this many washes. After blowing the engine block completely dry, the final step in the process before it leaves our shop is to install the new cam bearing that came with the overhaul kit. And with that, this old block is completely refreshed and ready to be paired with the rest of the overhaul kit and the head that we rebuilt and back in that old Massey Ferguson tractor. Thanks for watching, and we'll see you in the next one.